Hi guys, we're now on to our lesson on thermal radiation in the heat energy transfer topic. You're going to need, same as always, something to write with, something to write on, and you're going to need your attention span. Make sure you're focused and concentrating on what we're doing today. If you're using the video, pause, have a go at all of the questions and check your answers, and rewind and rewatch those explanations as much or as little as you need to. Let's get started. So let's think about how heat from the sun on those hot sunny days gets all the way through space to our planet on Earth. Now, all the methods we've talked about so far, we've zoomed in and we've looked at different particles and how the particles transfer it. But in the vacuum of space, there are no particles to transfer that heat. So there's got to be another way for that heat to get to the Earth. That thermal energy is transferred using waves. Not quite the same as a water wave, but it's an infrared radiation is what transfers it. Infrared radiation. And that is a kind of wave that can transfer thermal energy from one place to another without needing any particles. Now, all objects give off infrared radiation, even we do. If you've ever seen those thermal imaging cameras, they show the thermal radiation that's being given off by people and different objects. And the hotter an object is, so it's a really hot fire, the more infrared energy it's going to give off. So hotter means more radiation. Now, in practice, different coloured surfaces or different kinds of surfaces can give off and absorb more or less radiation than others. So if you've seen houses with solar panels on the roof, those solar panels are really dull and dark. Even on a hot sunny day when they're being lit up, they look really dull and dark, that kind of like really dark bluish colour. And that's because a dull and dark surface absorbs more radiation. So dull, dark surface, best at absorbing. And we want the kind of surface for a solar panel to be the best at absorbing the maximum amount of energy as possible. And opposite to that, surfaces such as if you look inside of one of those cool flasks that people have to keep things really cold or that you have to keep them really hot, they have a really light and shiny surface on the inside of them. So that light shiny surface is really good for that radiation to just bounce off of the side and reflect it. So a light shiny surface is the best at reflecting that radiation off. So if you've seen like tin foil that's used in cooking or in the kitchen, that's reflecting all of the heat back off to keep things warm. Okay, here are key points for bed. Pause here, make sure you've got this all written down before we move on. I'll give you give yourself a chance to self-test that. Look through it, say in your head, write it out, and get someone else in the house to quiz you as well if you can. Here are independent practice questions. Have a go at all of these. If there's anything you're stuck on, remember you can rewind and rewatch that video. Okay, here are your answers. Hopefully you got all of those. Again, if there's any bit you're not sure on, rewatch that explanation. But if you're happy with all of that, then well done, and that's all for today.